Hello everyone. Welcome to the part 3 of our discussion on function in C. In this part, we are going to discuss the function calling. So what is a function calling? To use a function, we need to call that function. Now, when we are calling a function, the context will be switched from the calling function to the called function. So suppose the main function is calling any function, then the context will be switched from the main function to the calling function. When a context is switched from the calling function to the called function, then all the statement present in the called function will be performed and it will come back to the calling function by executing either a return statement or by end of the function body. We have learned that in the function definition part. So when all the operations are over, then the context will be switched from the called function to the calling function and it will come back to the next operation to be performed in the calling function. We will going to see that in the example part. Next, main function is the first function which is called. The operating system makes the first call to the main function, and as we know that the calling function should return the value to the called function, then the main function will return the value, the return statement we are writing under the main function will return that value to the operating system. Library functions are, as we know that we do not need to declare or define any library function, but to work with the library function, we need to call the library function with proper input parameters. To work with the function, we need to call that function and that calling will be done from the other function. And the last point is any function can call any other function. So there is no restriction in the function calling part. So let us take an example which we have discussed in previous cases also. So this is our example where you can see that we have a user defined function add and some library functions like printf, scanf. So what is going on here? When the main function is called by the operating system, it will call the library function printf with this statement, that is the input argument for the printf statement. Then another printf statement will be called, and then the scanf statement, which is also a library function, is called with its proper input argument. Then we are calling the add function with the input argument x and y, and from this point the context will be switched to the called function, that is the AND function. Now what will happen over here? The value of x will be copied into m and value of y will be copied into n. So we already know that m and n are called the formal argument. So the value of x will be copied into the formal argument m and value of y will be copied into the formal argument n. Then the add function will perform its tasks and it will return the value of m plus n. Now from this point it will go back to the called function. In this case our called function is the main function, and it will go to the next task to be performed. What is the next task to be performed? To assign this value, returned value, to z. So from this point it will go to this point where z will be assigned with the value of m plus n. Now after that there is nothing to do in this statement, so it will execute this statement, printf statement will be performed and come back to the main function, then another printf statement will be function, and finally the context will be switched from main function to the operating system, and the main function will return this 0 value to the operating system. When the function went back to the operating system means its operation has been done. So from the function calling part, the first context switching will be done to the called function. After that, another context switch will be done and come back to the calling function. And finally, the final context switching will be done from operating system, from main function to the operating system in this example. So let us elaborate that example and let us note what we learned from the function calling part. So you can see that we are focusing on the function callings also only. So there are one, two, three, four, and five library functions calling, and printf statement is we are supplying the proper input argument. In the scanf statement we are supplying the proper input argument. Here we can see that we have already learned that we are passing the value of x and y to the add function. This x and y, the actual value we are passing, are called the actual argument. So in our example, x and y, value of x and y are the actual argument. And remember one thing, this type of calling function we call that call by value. Another kind of calling can be performed, that is called the call by address, which we are going to discuss later when we have covered the pointer part. Now C follows right to left calling convention. What does this mean? This means the value of the rightmost parameter will be passed first, then the second rightmost, then the third rightmost, finally the leftmost parameter will be passed. So when, as our example, the y value will be passed to n first, then x value will be passed to m. So from right to left, the parameter will be passed. And we always pass the latest updated value of the actual argument. Now the last point is very much important. The actual parameter will be stored in a stack available to called function only. So it will use a data structure, linear data structure called stack, and that stack will be available to that function only. Stack is nothing but a sequence memory space available to each and every function. Now, if we consider this is a stack, each and every block represent a memory space. What is the special thing about stack? Stack allows only last in first out operation. So the last operator, the last operand which is inserted in the stack will be taken out first. So the last operand which we pushing to that stack will be taken out or popped out first. So let us see this statement with this statement. What we are doing? We are calling a function following the right to left calling convention. So from this point we know that the value of y will be pushed to the stack first. So the y will go first into the stack, then the value of x will be go into the stack. Now, as we know that stacks follow last in first out, or we simply call it as LIFO, what will happen then? Then when we are going to take the value out of the stack, then x value will be popped first. After that, y value will be popped. Now, this is how a stack works, and this is how the things will perform in case of function calling. Now this stack will be available only to the called function. So this will be available to the add function only. Next, let us explore some examples. Now, in this case, we have a user-defined function f underscore sp. The purpose will be defined in the definition part. Here is the only declaration. So it will take two input arguments. As it will not return nothing, then we are making the return type as void. Now, obviously, you can see that the value we are passing the value, so it is a scenario of call by value. Now, what value we are passing? We are taking two value from the user, that is a and b, and we are passing that a and b to the function f underscore sp. So as it is not performing anything, it is not returning anything, there is no value to be stored, there is no variable which will store the return value of this one. Now let us first discuss how it will work. So first the printf function will be called, context will be switched from main function to the printf function, then printf to the main, similarly scanf, and similarly the next printf function. Next, what will happen? We are going to call this function. So when we are calling this function, the actual parameters will be copied into the formal parameter. You can see that the name of the actual parameter and the formal parameter are same. It is not that they are same, but their names are same, right? So when the function call has been made, then the context will be switched from this main function to the called function, that is f underscore sp, and the parameters will be copied. Then it will perform this printf statement. Then it will add 10 value to the A. Then it will add 20 value to the B. Then it will print the current value of A and B. As there is no return statement, so from this point, it will go back to the calling function, and where it will go, the next operation to be performed. So this is the next operation to be performed. So it will come to this printf from this point. This is 1, and after operation this is 2. So it will come to this printf statement, and then printf statement will show you back to main, where a equals to and b equals to the value of ab. Then from here, the main function will context switch to the operating system, returning the 0 value. Now, the significance of returning the 0 value is that when the operating system gets a 0 value by its called function, then it will understand the function has worked properly. Other than 0 value, it will, if we get other than 0 value, then the main function, the operating system will understand that there is some problem in the execution of that function. So that is why in each and every code will return 0 value to the from the main function to the operating system. Now let us discuss this function with these two point of view, the point 3 and point 5 point of view. So each and every function have its own stack. So in the memory for main function, there are two variables a and b. So two blocks of integer will be there, naming a and b. Now we are taking the value from the user and putting into A and B. So let us take, we have taken 10 and 20 value from the user. So and putting into A and B. So A value will be 10 and B value will be 20. Remember, this A and B will be available to the main function only. This is because of the scope of the variables. So we are going to learn about that in a later stage. Now, this 10 and 20 value is the value we are going to pass to the called function. So in the called function, there are two more memory unit of integer type whose name are also A and B. So when we are passing them, this 10 will be passed to A and this 20 will be passed to B. Remember, this is having a different memory location with this one. This is having a different memory location with respect to this one. So as their location or the address is different, they are not same. And these two will be only be available with the f underscore sp, that function. Now what we are doing in f underscore sp, we are running the printf statement, then we are adding 10 to it, so it will become 20, and as we are adding 20 to the b, so it will become 40. Now if I execute this printf statement, then what will happen? It will print, this function will print for this statement a equals to 20 and b equals to 40 for this printf statement. Now from here we are going back to the main function to this printf statement, and as we are switching back to the calling function, the availability of a and of this b will be gone. So the a and b available in main function is having the value 10 and 20. So this printf statement will print 10 and 20, not 20 and 40, right? So this is how a function calling will actually work. Here we are using the idea of call by value, and as we know that the function calling will be done from the parameter will be passed from right to left. So the b value will be first passed to this b, then the a value will be passed to this a. Now let us run this code and see what output we are getting. So this is the code we are talking about. You can see that we are running the similar code. So let us first compile this code. Now let us run this code. So it is asking for the value of a and b. Let us put 10 and 20. So if we go back to the code, what is the next statement? The printf. So it will show in main a equals to 10 and b equals to 20. Then it will call the f underscore sp function. So it will show in f underscore sp a equals to 10, b equals to 20. Then it is performing the updation value of a and b. So once again it will show in f underscore sp the new a equals to will be 20, b equals to 40. Then it is going back to the main function, and where it will show back to main with a equals to, as we have already discussed, this a and b will not be available to main. So it will show a equals to 10 and b equals to 20. So let us check that output we are getting or not. So you can see that we are getting the exactly what output we are expecting. Now let us take example where we are going to establish the idea that a function can be called from any other function. Now, consider this example where we have two user-defined functions. We have declared the function A and the function B. They are not going to return anything, so our return type is void, and they are not taking any input argument, so I haven't mentioned them. Now in the main function, what we are doing, we are first statement we are printing is in main. Then we are calling the a function. Then it is saying that the main function is saying that back to main. Then we are calling the b function. Then the printf statement will be shown that back to main. Then the main function is returning the value to the operating system. Now in the a function, what we are doing, it is showing that it is in A, and in the B function it is showing that it is in B. So let us run this code and see what the output we are going to get. So if we consider this one, what we are actually going to get is that the first operating system will call the main function will execute in main, then it will call A. So in the A function it will show that in A, then switch back to the main function, so it will show back to main. Then the B function will be called where it will show in B, then switch back to the main function where it will show back to main. Then the context will be switched to the operating system. Finally my function will be over, execution of the function will be over. So let us run this code. I think it is already compiled. So we are getting the exact output we are expecting in main, in A, back to main, in B, back to main. Now, so you can see that the main function is performing the calling of A and B. Now let us take another example with the same kind of declaration of A and B, but here the function definition A is different. Here in the function of A, what we are doing, we are printing in A, then we are calling the function B, then then it will execute the function B and come back to the main A function, come back to the A function, and it will show back to A. From there it will go back to its calling function. So you can see that here the B function is called from the A function. So if we execute this code, let us first compile this one. The output will be in main, then it will call the a function. So in a function, it will show you in a. Then in the a function, it will call b function. So it will show in b. Then from here, it will come back to the a function. So it will show back to a. And from this point, it will go back to the next point, the next statement to be executed in a function. So it will show you back to main. From there, the main function now will call the b function, so it will show in b once again. Then from here, it will go back to the main function at this statement, so it will give you back to main. Finally, the return value will be gone to the OS, and the main operation is done for this code. So let us check we are getting that output or not. So as we are expecting in May, then in A, then in A, in B, then back to A, then back to main, then in B, then back to main. So the point of this code is that the A function is calling the B function. Now what will happen if we call the a function with the from the b function? As we know that any function can call any function, so this is possible. First thing, this is possible. Now as a is calling b and b is once again calling a, then what will happen that we will going to have a loop between this statement and between this statement and this statement. So it will be a continuous loop, and that continuous loop will be stopped when there is no space in the stack. With stack, as we have mentioned, that function calling will be performed using a stack. So when the stack space is over, there is a limitation in the stack space. So when the stack space is over, this looping will be stopped. So the main idea is that for this, it will loop for a infinite number of time actually, but as the stack is not available for that amount of time, so it will stop at some point later. So you can see that it is going on, and you can say that it is showing in A, in B, in B, in A, and at this point, as the stack is overflowed, so that is why it has been stopped. Similarly, if we call the main function from the b function, or you can call the main function from a function also, because any function can call any function, so it will give you the same kind of effect. But the output is little bit different because it will show you in a, then in it will first show you in main, then in a, then in b, then once again it will go back to the main function, so it will show in main, in a, and in b, and this will continue for a finite number of time. Actually it should run for infinite number of time, but as there is a limitation in stack, it will stop at a finite state. So if we run that, so you can see that in main, in A, in B, you are getting this sequence of output. Let the run stop. So you can see that we are repeating in main, in A, in B. We are stopping at that point because of the stack overflowing. So from this last two example, maybe it will be clear to you that any function can call any function. So is it possible that a function can call itself? The answer is yes, and this kind of calling is called the recursion, which plays a very important role in case of any programming language. So in our next video, we are going to discuss about the recursion. So thank you, and see you in the next video.